Hello everyone, once again welcome back to the DSA with DAX series. Myself Laks Patel, and this is the DSA series where you can find DSA from absolute beginner to the advanced level. Okay, so firstly I'll tell you about something our series. Okay, our series I started from 50 days ago where we'll started from absolute beginner to master DSA and improve your problem solving skill. Okay, so we started from the array string. Afterward we'll see object, set, inbuilt functions, map, filter, list. Okay, so now like that we are today moving with the question with search insert position without using an entirely for loop from 0 to the end of the array. Okay, this is the where you start from binary search method. Okay, so I'll explain that part and later on we'll discuss about how we can write code for that. Okay, so and one more thing, yesterday we saw a question number 13, Roman to integer question. Okay, where Roman number is given, where I, X, V like that number is given, and you have to convert it to the integer. Okay, so if you does not watch yesterday's video, you can check out that video link in I button. Okay, so now I'll start with the firstly question explanation. So the question is given a sorted array of distinct integers. So first they'll clear to you, they given you a sorted array of distinct integers and the target value. Also you are given a target value. Return the index if the target is found. Okay, you have to return index like which index target value is stored inside your array. If not, return the index where it would be if it were instead in order. Okay, so if it won't find in your array, you have to write an index. Okay, where target should be found. Okay, so like there if there is a number 157 and target value is 6, so you have to write first. So for like after first index there is a our what is target value is there. Okay, in case of their given to you, you must write an algorithm with order of log n runtime complexity. Okay, so the runtime complexity is less than order of n, it's exponentially lesser than order of n. Okay, it has to be order of log n maximum. Now we'll see the example so you got clear about that part. So example one, input nums equal to 1356, target is 5. Target is present in the array, so the index of that is second index. Now I'll see example 2, nums is equal to 1356. Okay, and target equal to 2. So target 2 is not there present, but it's come after 1. So the index of 2 is gradually becomes the first index. Okay, like that 1356 are present, target value 7. So it will come on fourth index. Okay, so I hope you got clear about where to insert and how to insert. Now we'll see the conditions. So first condition they given to you is nums dot length is between 1 to 10 to the power 4, and the nums of I value is also between minus of 10 to the power 4 to plus of 10 to the power 4. Okay, and nums contains distinct values stored in ascending order. Okay, each and every nums are sorted in ascending order, and each and every are distinct. Okay, no one is same or similar given. Okay, and the target value is also between minus 10 to the power 4 to plus 10 to the power 4. Okay, so I hope we got clear about questions and its example. So now we'll discuss about how we gonna write a code which should be follow this order of log n complexity. Okay, okay, so firstly we'll discuss about the how we can manage to time complexity in order of log n. Okay, then after you understand what is the approach to do this question. Okay, so the method called is binary search to searching in an array or an object with the time complexity of order of log n. Okay, so generally you search from the unsorted, like unsorted array or unsorted array from the first index to last index. It will check in worst and worst cases first to the last element each and everything. Okay, but in binary search it's only applicable for sorted arrays. Okay, so in sorted array you know that your first element is the lesser than second element and like that so on. So binary search starting from the middle. Okay, it will check that middle element is the greater than or smaller than your current element. Okay, your current element which whatever you have to find in your uh, uh, array. Okay, so let me show you like one example. If you have to find 5. Okay, you have to find 5, and your middle of the array is 4. Okay, so now it know your middle is smaller than, so it move to the array is like that, 1 2. Okay, so firstly 4 is the middle, so check for 4. Okay, if 4 is smaller than, so it will again half of that part. Okay, take middle of this whole thing. Okay, so middle of this whole thing becomes 6. Okay, so it will check that 6 is or not, so it will know that 6 is greater than, so now remain is 5, so it will check that 5 and return that the 5 is the number. So currently you checked just three cases. Okay, one is 4, another one is 6, and afterward is 5. You just check it three cases, but in case of you use normal search, so first, second, third, fourth, fifth, it will take 5 test cases to know that whether which element is the currently your element. Okay, so this is the binary search method called. It will take half of your result and finding it. Okay, if it's greater it will move to the next part, if it's lesser it's move to the below part. Okay, so we have to use that binary search method in this our question to make time complexity of order of log n, and this is our first approach. So first we'll use one left side variable, another one right side variable, sum of that both variable and divide it by 2. So now we got our middle variable, and taking that value and checking it with the target value. If it's equal to it, yes, there this is the correct value, and we'll return that index of that middle. But in case it will not, so now we have two conditions. First is that our target is greater than middle value or less than middle value. If it will greater than middle value, we'll now change our left side variable with the middle value. Okay, in first case your left variable is 0 starting from 0 index. Now it will replace with the half value of your array, so now it will like a middle length to the end of the array, first part removed. Okay, and it will again find new middle variable from the middle of your array to the end of the array, and like that it process going to the when it can find the particular solution of that. Okay, so this is our first approach. I hope you got clear about the binary search and how this gonna work and how we'll apply that. So I hope you got clear about this. If you find any doubts about this, you can ask me in comment section. So now we move to your code part. Okay, so let's start with our first on binary search approach. So first we will left variable starting from the 0 index. Okay, it's first part of the our array. Then we use left, right. Okay, nums dot length minus 1, so it will the end of the our array. Afterward we use one while loop, because we does not have to attach each and every index, that's why I am using while loop. Whenever left is less than and equal to right, okay, that time this loop is gonna continue. Now is const mid equal to math dot floor. Okay, it will find the middle of the our given, and the syntax we given to it is left plus right variable and divide by 2. Okay, this is the our middle. Okay, now we use if our mid, sorry, our array is nums, so nums of mid is equal to our given target. So it's bingo, you got your value directly, so use return mid, it will index of the mid, it will return. And if it's not it value, so we'll use nums of mid is less than target. Okay, in case of our nums of mid is less than target, target value is greater than it, so it will in the second part of the our array. So now we have to increase our left side value, so now left value is becomes mid plus 1. Okay, we move to the another half part of the our array. Okay, first half part will be removed because the value doesn't exist in that part, that's why we are in the second part. Now else condition, in case right, okay, our target value is less than our nums of mid, so that part we have to come to third part, so we'll convert right to the mid plus 1 like that, as we'll done in left part, as we done in right part. Okay, one more thing we have to do is, the question said you, if not, okay, the target is not found, so return the index where it would be if it were inserted in order. Okay, so in case of we couldn't find that the target value is given in array, so we have to return an index where it could be if it will inserted. So for that, it will be return left. Okay, left value of we taken left character. Left character stores the values of characters which is used currently. Okay, so left is will use that part. So I hope you got clear about this approach. Firstly, we'll declaring something is two variable. You can take any two variable, one in from first and another from last, and taking half of part of that. Okay. And one more thing you have to know, that is, whenever you gonna use a binary search method, the array is must be sorted. Okay. Now it will showing time limit exceed error. Wait, we'll check. Okay, so it will running test cases. Okay, so you can see that our answer is accepted. Now we have mistake here. Okay, in write this part, we have to take mid minus 1, not mid plus 1. That's why it will showing time limit exceed, because you increased one test case, so our binary search failed, and that's why our time limit exceeds. Okay, so now we'll submit for further lead code test cases. And now we'll discuss about this time and space complexity for this code. Okay, for this code, our space complexity remains is order of 1. Okay, because we does not take an entirely new array or object as same as our given nums array. We using just only three variables. First is left, another is right, and third one is mid. Okay, and taken comparison between each and everything. So space complexity is order of 1, and time complexity will for time complexity we'll have to understand something like that. Whenever you working with the binary set, time complexity is order of log n. Okay, so time complexity is order of log n, and our space complexity is order of 1. And if you have to check for that, okay, let I show you the checking time complexity. Okay, lead code showing us and feature to check our code's time complexity. So it will submitting. After that, we can check out it. And this now you are in a advanced level of questions. Okay, binary search, sort, tree, algorithms. Okay, and data structures, set, list, tag, queue. Okay, these topics are started. Okay, now you are on advanced level of lead code. So now the thing is, you have to do as much as thing as possible by yourself. Try to do question by multiple approaches. Think about the time, space, complexity. As much as possible, you can try to reduce it and optimize it code. Okay, it will showing us. Okay, it's basically order of log n. Okay, because otherwise it will won't accept our answer. Okay, and you can check by other time and space complexity analyzer, or you can use ChatGPT. And this is our day 50 of our DSA DAX series. Okay, and if this video got 100 comments, so we'll continue this series for further 51 to 100 questions. Okay, and advanced lead code DSA series. Okay, and in that series we'll learn about multiple data structures and its applications and its question solving. Okay, and in that video, firstly, I'll show you which question is different series. Now you'll understand multiple concepts. So for that series, firstly, I'll explain the new topic in that video and question of that topic, and given you for three, four approaches. You have to try that approaches by yourself. One, two approach I'll solve in that question, and another one you have to try by yourself. Okay. So I hope that's a very great journey with you. Okay, with this 50 days series. If you have to check out any other video, you can check out by the link in I button of our playlist. And in playlist, if you not started yet DS with the series, go to day one where I'll explain each and everything about this series. And this is the last video of our first stage series. As I previously said, if 100 comments got, we will continue for 51 to 100 days. Okay, so, and if you have to check out our code and explanations of this series, you can check out our GitHub repo link where each and everything is updated. Okay, till 50 days. For further, you have to check comment section. Okay, and now later on we move to the something another like this, which will help you to get know more about coding programming. Okay, next series is about that. So thanks for watching the video. Meet on the next series, another series.